All right, so that was a cube root. Let's do one a little bigger. What about a fourth root? You do it the exact same way, except you're always looking for groups of whatever number is right here. So with a cube root, we look for groups of 3. With a fourth root, we look for groups of 4. So if I were to do the prime factorization of 48, let's see, that'd be 2 and 24 is an option. 24 is 6 and 4. 6 is 2 and 3. 4 is 2 and 2. So if you look at all of our factors, I have 1, 2, 3, 4 2's, so that's a group. Make a big circle. And I have 1, 3 left over. So for that whole group of 2's, one of them comes out front. For that 3, it stays underneath. And notice I keep writing this. You want to make sure you keep writing what kind of root it is so you don't lose that while you're working. All right, so those were all with numbers. Let's talk about one that has variables in it. So we'll go back to a square root to start. 128 p to the 4th q squared r cubed. Now I would start with the number because you already know how to do that. Just for the sake of ease, let's do the prime factor method. So 128 could be, let's see, 2 and 64. 64 is 8 and 8. 8 is 4 and 2. And 4 is 2 and 2. So again, we're back to a square root, so we can circle pairs. So here's a pair, here's a pair, here's a pair, right here. And I have 1, 2 left over. So I have 1, 2, 3 that I can pull out, and 1 that's left over. And we haven't changed the letters at all. Haven't done anything to them yet. All right, for the letters, we're going to do the exact same thing. If I have p to the 4th, what that means is, let me rewrite this a little bit. So 2 times 2 times 2 is 8. What that means is I have p times itself 4 times. So 1, 2, 3, 4 p's. I have q squared, so that's 1, 2 q's. And I have r cubed, which is 1, 2, 3 r's. The same thing as the numbers, I'm allowed to pull out groups of 2. So I have 2 p's, 2 p's, 2 q's, 2 r's, and 1 r left over. So just like with the numbers, for every group that I've circled, I can pull one out front. So I can pull out 2 p's, a q, and an r. For everything that didn't get circled, it has to stay underneath. So that last r that was by itself is still underneath here. Now the only thing you can do is simplify this p times p a little bit to get 8p squared q r times the square root of 2r. All right, for our last example, we're going to kind of combine what we know. So we're going to have a cube root, and we're going to have some variables. Now the idea is the same. This -3 is just a number out front. We'll deal with that in a minute. I have a cube root, so I'm looking for groups of 3, which means I need to factor this number. And you can either write out these letters like we did last time, or you can sort of think of them as division, which we'll talk about in just a second. So let's start with the number. That's where I always start. I have 1,000. It's kind of a big number. Let's see. I know that'll split into 10 and 100. 10 is 5 and 2. 100 is 10 and 10. 10 is 5 and 2. Now this time, I have a group of 3 5's, and I have a group of 3 2's, because 1,000 is actually a perfect cube. If you type in the cube root of 1,000, you get 10. So I can pull out a 5 and a 2 out front. They're just going to get multiplied by this -3 that was already there. Sorry, 5 and 2. So the number is completely gone. There's nothing left over of it. Which means out front I have -3 times 5 is -15, times 2 is -13. Now for the letters, again, you could write out 8 x's, 3 y's, and 4 z's and circle groups of 3. Or you can think about just dividing. So I want to know how many groups of 3 are in 8. Well, there's 2 full groups of 3. That gets you up to 6 with 2 left over. That means I could pull out an x squared. And I have an x squared left. Or again, you could write out 1, 2, 3, 4, 5, 6, 7, 8 x's and circle the groups of 3. And you have 2 left over. Same thing with the y's. There is 1 group of 3 in 3 with none left over, so I can pull out 1 y and there won't be any left underneath. Or we can write out 3 y's. So circle them all, you won't have any left over. Same thing with z to the 4th. 3 goes into 4 1 time, so there's 1 group of 3 with 1 left over. So I have 1 z out here and 1 z in here. Or you can write out 4 z's, circle the group of 3, and have 1 left over. Either way, this should be where you end up.